Hi, in this video we're going to look at balancing chemical equations. We're going to start with a reaction that you did in your lab. So magnesium combining with oxygen to produce magnesium oxide. So pause the video and write each of these compounds. Okay, hopefully you remembered that oxygen exists as a diatomic molecule. So we'll have magnesium reacting with oxygen to produce magnesium oxide solid. Now the magnesiums are already balanced, but we'll need a 2 in front of the magnesium oxide to balance the 2 oxygen atoms in the diatomic oxygen molecule. That's gotten our magnesium's atoms out of whack, so we'll need to put a 2 in front of the magnesium, and now we have a balanced chemical equation. The next one we'll look at is shown here. Pause the video and write the balanced formulas for each of the compound in this equation. Alright, you should have ammonium dichromate solid to yield chromium 3 oxide, nitrogen gas, and water vapor. So we want to look at the chromium first, since nitrogen is on its own. Hydrogen and oxygen, of course, we save for the end. Chromium, already balanced. So the next thing we'll look at is the hydrogen, since the oxygen is in 2 different compounds on the product side. Hydrogen, we have 2 hydrogens here in the water molecule and 8 in the ammonium dichromate. So you'll need to put a 4 in front of the water molecule. The next thing to look at is the oxygen. 3 oxygen here plus 4 gives us 7 oxygen atoms, and there are 7 oxygen atoms in the ammonium dichromate, so that's fine as well. Lastly, let's look at the nitrogen. 2 nitrogen atoms in ammonium dichromate, 2 in the diatomic nitrogen molecule, and our equation is balanced. Next one, let's look at this chemical equation. Pause the video and write the formulas for each of these compounds. Alright, you should have ammonia gas reacting with oxygen gas to form nitrogen monoxide gas and water vapor. Now save oxygen and hydrogen until the end, meaning we look at the nitrogen first. Nitrogen is already balanced. Oxygen exists on its own here, so the next thing we should look at is hydrogen. With 2 hydrogen here and 3 in the ammonia, we're going to need to have a coefficient of 3 in front of the water and 2 in front of the ammonia molecule. The next thing that we'll need to look at is the nitrogen atoms. So if you've got 2 nitrogen atoms here, we're going to need to add a coefficient of 2 here as well. So now that has gotten the previously balanced oxygen atoms unbalanced, so we'll need to look at that. So on the product side, you have 2 plus 3 to give you 5 oxygen atoms. Because oxygen is a diatomic, you're going to have to put that in as a fraction of 5 over 2 so that you have 5 oxygen atoms. Now you don't want to have any fractional coefficients, so multiply everything through by 2, and this will give you the balanced equation. Last reaction. Write down the chemical formulas for each of the compounds shown here. Okay, we've got molybdenum 4 sulfide reacting with oxygen gas, produce solid molybdenum 6 oxide plus sulfur dioxide gas. Okay, we're going to first look at the MO, which is balanced. Oxygen is on its own, so we'll look at sulfur next. And we need 2 sulfur atoms in the sulfur dioxide. So now Coming down here, now that we've got molybdenum balanced, sulfur balanced, let's look at the oxygen. 3 plus 4 gives us 7 oxygen atoms, so we'll need a fractional coefficient here because of the diatomic oxygen. Now, in order to get rid of that fractional coefficient, multiply everything through by 2 to give you 2, 7, 2, and 4. And now you have a balanced chemical equation. These are 4 examples of chemical reactions. There are many more in your book and on your website. Good luck!